Hi everyone, today I'm going to teach you about exponential notation. Exponential notation is a different way of writing numbers. So let's first start by talking about standard notation. Standard notation is a regular number. It's how numbers are usually written. Uses regular place value, regular digits 0 through 9, commas to separate the periods, like this number here, 5,236,986. Exponential notation, though, is a short way of writing repeated factors. This uses a base and an exponent. The base tells you which number you multiply, and the exponent tells you how many times you multiply it. So, for example, here, I have 4 to the third power. We can also say this one is 4 cubed. That means 4 times 4 times 4, which equals 256. That's a pretty far away from 12, which is 4 times 3, isn't it? I like to think of exponents as being big and beefy, like this bodybuilder. They're not just regular multiplication problems. Let's talk a little bit about exponents. Exponents have a base and an exponent. So the base is the number that you multiply. So let's say that we multiply the number 7. And let's say that this number is 7 squared, 7 to the second power. That is the same thing as 7 times 7. So you can see that we use the exponent here to tell us how many times we multiply 7 times 7. Let me give you another example. We could do a base of 12 to the power of 5. That means 12 times 12 times 12 times 12 times 12. Do you think this is going to be a big number, or do you think it's going to be a small number? Well, 12 times 12 times 12 times 12 times 12 is a whopping 248,832. That is pretty big and beefy. Let's try some together. The first thing that I want you to do is write the number 3 to the fourth power. When you do this, I want you to write it in repeated factors. Let's see what that might look like. I'm going to give you a couple of moments to do it on your own. Okay, when we do 3 to the fourth power, we're going to multiply 3 4 times. 3 times 3 times 3 times 3. Is that what you got? Let's have a quick review of prime factorization from Unit 1. Prime factorization is when you break a number into its longest factor string. The longest factor string is going to have all prime factors. Let's remember that a factor is a number that another number can be divided by. So, for example, we could take the number 12. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And I set this up kind of like a factor rainbow so that we could see that I listed all of the factors. Another thing to remember is that prime numbers have just two factors. They have the factors of 1 and itself. For example, 3 is a prime number. The only two factors that 3 has are 1 and 3. So when we find the prime factorization of a number, we can start, I usually like to do a factor tree. We can start with the number 12. And I like to think about any two factors that go into 12. A factor pair that goes into 12. So I maybe will think about 2 times 6. Okay, now here I'm going to stop and ask myself, are either of these numbers prime, or do either of these numbers have only one factor, one in itself? Well, 2 has only one factor. 2 is the only even prime number. Do you know why? The only even prime number because all other even numbers can be divided by 2. So let's take a look at 6. 6 isn't prime. 6 has a couple of factors. It has 1 and 6 and 2 and 3. Now we never put the number 1 into a factor tree because it won't really get us anywhere. So we're going to list 2 and 3. I'm going to put a circle around 2 because it's prime. And a circle is kind of my stop sign. And I'm going to put a circle around 3 because it's also prime. Now, the prime factorization of 12 is 2 times 2 times 3. Now, I bet you're wondering what on earth this has to do with exponents. Well, we can write this number now. Instead of writing it as 2 times 2, let's think back to what we learned about exponents. This is 2 to the second power times 3. Let's try finding the prime factorization of another number. Let's try finding the prime factorization of the number 24. I want you this time to work right along with me. Okay, I'm going to make a factor tree for 24. Now your numbers might be a little bit different than mine, but that's okay because in the end we're going to have the same prime factorization. Prime factorization is kind of like a fingerprint. Every number has a different prime factorization. Kind of cool. I'm going to start thinking about the numbers 6 times 4. I know that 6 times 4 is 24. You might have started off with 2 times 12, or maybe you started off with 3 times 8. Either way, it doesn't matter. Now, I know that 6 is not prime because it's an even number and it's not 2. So I know that it'll break down into 2 more numbers. 6 is equal to 2 times 3. 2 is prime. 3 is prime. Now I want you to try to break down 4. 4 is equal to 2 times 2. 2 is prime, and 2 is prime. So 24 is equal to 2 times 2 times 2 times 3. You'll notice here that I'm writing these in numerical order. I'm going to rewrite this part, 2 times 2 times 2, using exponents. So I did 2 times 2 times 2. I did that 3 times. So that's 2 to the power of 3, which is the same thing as 2 cubed times 3. So today we've done a bunch of prime factorization and turning numbers into their exponents. So I have a few problems for you to practice and try to figure out if you understand. The first one is 3 to the power of 4. This one I want you to write using repeated factors. That's going to look like the number that you multiply over and over. The second one, I want you to write 4 to the power of 2. This one, I want you to write in standard notation. Remember that standard notation is just the regular number. And the third one I want you to do is I want you to find the prime factorization of the number 20. When you do this, I want you to write it with exponents. So that's a challenge problem. My handwriting is not too great on here, so I apologize for that. These are the 3 problems that you'll need to bring into class tomorrow. Thanks so much for watching. Have a great night.